All right, so let's look at what we started the other day with. We looked at the fundamental theorem of algebra, which essentially you already know. What is the degree of this polynomial here? 5. So that means that there are at most 5 zeros. Some of those zeros are going to be rational, some are going to be irrational, some are going to be imaginary. Those are your 3 possibilities. Rational and irrational zeros will cross or touch the x-axis. The imaginary zeros will not. So we looked at, well, what if you're given a 0? If you're given the only new thing to this today are your imaginary zeros. So if I gave you a 0 that's imaginary, we also know that imaginary zeros come in what? Pairs. So if I gave you only one 0 of 3i, you should automatically know that it also has another 0 of negative 3i. Then you'd have to write those as a factor. So a factor is a binomial. So it's always x minus whatever the 0 is. So x minus 3i would be x minus 3i. X minus a negative 3i would be x plus 3i. Essentially, you're going to change the sign here and put it behind x. But what if we have a more complex 0? Shuffle, shuffle, a complex number. You've got a real part and an imaginary part. So if I gave you just 4 plus 6i, again, you should know that the other 0 would be 4 minus 6i. So with the complex numbers, they are conjugates of each other. Notice that the 4 did not change signs, only the imaginary part changed signs. So how do you write that as a factor? We're going to take x and subtract the entire 0. And again, x and subtract the entire 0. So you essentially distribute that negative into the parentheses. So you get x minus 4 and minus 6i. I changed the sign of the 4. I changed the sign of the 6i. So if you want to skip this intermediate step by just realizing, oh, when I put it behind x, I'm going to change both signs. So same thing here. Change both signs, you get an x minus 4 and a positive 6i. So your 0 or your factors for your imaginary numbers are a little bit more complicated than your zeros for your just imaginary. So complex 0 is a little bit more complex. It's a Monday morning now. We really should get to that. All right, so then you're going to have the same types of problems that you had in 2-4, where you have to find the zeros of a polynomial function, and you're not given any of the other zeros. It's a shot in the dark. We have an unmeasurable number of zeros we could choose from. So we learned in 2-4 that you could take p and divide it by q. Well, p is the coefficient of your last term of the polynomial, and q is the coefficient of the first term of your polynomial. Your polynomial must be in descending order, which this one is. And this last term, bless you, happens, and again, happens to be a constant. It doesn't matter, it's still a coefficient. So you're going to take all the factors of p and divide it by all the factors of q. So your factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Your factors of 1 are plus or minus 1. You have to take every item in the numerator and divide it by the denominator. Well, because the denominator is just plus or minus 1, isn't the numerator our possible factors? So I don't have any fractional factors for this particular one. They're all integers. So I like to start in the very middle, closest to 0, and work my way out, because as I'm using synthetic division to try to find my zeros, I want to look for my upper and lower bound rules, because those are going to help me eliminate choices in synthetic division. So if I start at 8, well, 8 is the biggest number, I'm less likely to find my upper bound because 8 is the biggest number. But if I start in the middle at 1 or negative 1, which is always going to be the middle, then I can work my way out, just based on what I see. So as I'm doing synthetic division, I'm looking at the bottom line, right, Quins? You're zoning on me. So when you look at the bottom line, you're looking for 2 different rules. If I put a positive number on the shelf, what am I looking for on the bottom line? Positive number on the shelf implies I'm looking for an upper bound. Go back to your 2-4 notes. Positive number on the shelf, I'm looking for the last row to be all what? Positives or zeros. They can be all zeros, they can be all positive numbers, they can be a mixture of positives and zeros. But if I put a positive number on the shelf, and I find that my bottom line are all positives or zeros, I've found my upper bound. So then I would know not to choose any numbers above that in my possible factors. So let's just say that I put 2 on my shelf. I put 2 on my shelf and I went through the synthetic division. I did not get a remainder of 0, but all of my bottom numbers are positives or zeros. I would know that 2 is my upper bound and that I should not choose 4 or 8 because they're bigger numbers than 2. All right, let's say that I put -2 in on my shelf. It's a negative number. What am I looking for on that bottom line if I don't get a remainder of 0? No. Alternating positives and negatives. So it's kind of easy to remember that if I put a negative number on the shelf, it's negative, I want alternating positives and negatives. It can go positive, negative, or it could go negative, positive. It doesn't, you don't have to start with a positive number. Just so that they're all alternating, including the remainder. If I put a -2 and I found that alternating signs, I would know that there's no choices less than -2. I found my lower bound. So I wouldn't try -1. But in my world, in my reality, I probably would have already tried -1. So let's go ahead and start guessing and checking. So that was step 1. So step 2 is to start your synthetic division. I typically like to choose what? 1. Well, before I can write down my coefficients, you need to look to see, are you missing any terms in here? What am I missing? I'm missing right here, 0x to the 4. So I have to have a 0 as a placeholder. So I've got 1, 0, 1, 2, -12, and 8. We're all okay with that? Draw your L, your vertical line, and your shelf. What's wrong, El?
I was just wondering why it was
Are you okay? Okay. We have to account for all x terms. All right, so we are trying 1. We always like to try 1. It's easy. So bring down the first term and start the multiplication pattern. So you've got 1 times 1 is 1. Add down, you get 1. 1 times 1 is 1. Add down, I get 2. 1 times 2 is 2. Add down, I get 4. 1 times 4 is 4. Add down, I get -8. 1 times -8 is -8. Yippee skippy, I get 0. So what does that tell you? This is a 0. All right, so on my 0 line, I'm going to go over here and I'm going to write a 0 of 1. So what would its factor be? Opposite sign, x minus 1. That's its linear factor. Note to self, we found a 0. You need to keep trying 1 because it might be a double, a triple, a quadruple root. It might have multiplicity to it and you won't know it if you don't try it. And especially because I have an x to the 5th. I'm looking for 5 zeros. It's highly possible we have multiplicity in there. So I'm going to continue with this part only and I'm going to test 1 again. If I come up with a remainder, then I know that there's no multiplicity. But I went from x to the 5th, and now this is x to the 4th, so I only have to find 4 more zeros. Let's test 1 again. So bring down the first term and start that multiplication process. 1 times 1 is 1. Add down, 2. 1 times 2 is 2. Add down, 4. 1 times 4 is 4. Add down is 8. 1 times 8 is 8. Yeah. Add down, we get another 0. So I'm not going to write a second 1 as a 0 because I only need to write the zeros down once. But when it comes to my factors, I am going to put a squared here, but I'm going to wait because I don't know, maybe it's to the 3rd. We're going to test 1 again. We're going to just keep testing it till I don't get a remainder of 0. So here we go, one more time. And by the way, aren't I now down to x to the 3rd? Isn't this x to the 3rd here now? So I really only have to get one more 0 before we use our factoring rules. So bring down that first term and start to multiply. 1 times 1 is 1. Add down is 3. 1 times 3 is 3. Add down is 7. 1 times 7 is 7. add down is 15. Question. Okay, so I did not get a remainder this time. But, what's your last row? What do you notice? We put a positive number on the shelf. All the answers in that bottom row are all positives. When you put a positive number on the shelf, you're looking for that last row to be either all positives or a mixture of positives and zeros. And so haven't I found my upper bound? I have found my upper bound. Notice when we used 1 the first time, this didn't show all positives because we hadn't exhausted all multiplicity. This one did show all positives. So right there, it could have told you that that was it. That was your lower bound you were done, because we do have all positives. But try it again. She may not still believe that that is true, so we tried it again. Sure enough, we did not get another multiplicity. I'm just going to show you the graph. So I put the original polynomial into the y equals, and here's its graph. What do you see to the right of 1? Nothing. And isn't this kissing the graph at 1? So that's showing that multiplicity, because it's just touching the graph and bouncing off. So we do have a multiplicity of 2, because I got another one here. So I'm going to go over here, and I'm going to put a square before I forget. But I'm not writing down another 0. Now, also keeping in mind that if this does not have a remainder of 0, then I'm using this right here. This is what I'm starting off with for my next choice. Because 1 is my upper bound, I also know that I'm not going to choose positive 2, positive 4, or positive 8, because 1 is my upper bound. Those choices are eliminated. No positive 2, no positive 4, no positive 8. So I just cut my choices in half. I saved myself a lot of work looking for that upper lower bound. So step 3. If I tried positive 1, it would behoove you, which means to your benefit, to try negative 1. So I'm going to go with what we ended up with on 1. So 1, 2, 4, 8, and 0. Remember, I just need one more, not 0. I just need one more 0. So I'm going to try negative 1, because I haven't tested that one. And even if it doesn't work, I can test it for a lower bound. So negative 1 times 1 is negative 1, add down is positive 1. Negative 1 times 1 is negative 1, add down is positive 3. Negative 1 times 3 is negative 3, add down is positive 5. So I did not find a 0. And let me note that we have a negative number on the shelf. All the numbers on the bottom are positives. Does that mean anything? But this is a negative. And we already found our upper bound. So with a negative, we're looking for alternating signs, positive, negative, So the thing I'm pointing out here is make sure you understand what you put on your shelf. So this is not an upper bound because we did not put a positive number on the shelf. So this is just one that didn't work out. So now I know, out of my choices, that it's not 1, well, we had 1. So I don't have to do 1 again, right? I'm not going to do negative 1 again. So all I have a choice left is negative 2, negative 4, negative 8. I'm just going to start to work my way backwards. I'm going to go to negative 2. So I'm going to start with 1, 2, 4, and 8 again. But this time I'm putting negative 2 on the shelf. Drop down the first. 1 times negative 2 is negative 2. Add down, we get 0. Negative 2 times 0 is 0. Add down, we get 4. Negative 2 times 4 is negative 8. Add down, yeah, we get a 0. So that means that negative 2 is a 0. So on our 0 line, we're going to put a comma negative 2. And what's the factor? We get x plus 2. So how many factors do I have total? 3. I still have how many more left? 2. So aren't I down to my quadratic then? I have 2 factors left. So this is x squared plus 4. Right there I can stop and go directly to factoring. So my step 4 is to factor. So we're going to factor x squared plus 4, because the 4 is positive, set it equal to 0, equals 0. You cannot factor the sum of 2 perfect squares. If you can, I'm going to nominate you for that Nobel Math Prize. No, you don't just put an I on it, because we haven't solved for anything yet. Keep jumping. So we're going to subtract 4, so we have x squared equals a negative 4. How many solutions am I looking for? 2, because it's an x squared. So when I take the square root of both sides, it's plus or minus the square root of 4. Remember, this square root of 4 is really plus or minus the square root of 4 times negative 1. Right? So when I get x equals plus or minus, what's the square root of 4? 2. What do you write for the square root of negative 1? I. So that finishes out my zeros. So I have a positive 2i and a negative 2i. So what's your linear factor for the positive 2i? X minus 2i. And for the minus 2i, x plus 2i. So change the sign. So now I have 5 factors altogether. I've accounted for all of my zeros. These are all of my zeros here. There's only 4 of them. But the next thing that Math Excel is going to ask you are, out of these zeros, which ones are x-intercepts? Which ones actually cross the x-axis? There's 1. How about negative 2? How about 2i? There's touching and it still counts. So how about 2i? Nope. And negative 2i? No. So only 1 and negative 2 become your x-intercepts. So not all zeros are x-intercepts, but all x-intercepts are zeros. Right, because I got down to my quadratic. If it had been an x cubed, then yes, I would have tried 2 again. Good question. Yes, ma'am. Would it be what? Oh, okay. He asked, why is it that when I got here, I knew that I wouldn't be choosing positive 2, positive 4, positive 8? Is that your question? Because of this bottom row here, all of them are positives or zeros, and that tells me I found my upper bound. So there's no possible factors greater than 1 that are real. So that means that out of all of these possible factors, 2, 4, and 8 are greater than 1. They're not going to be possibilities. So I'm not even trying. Yeah, you could try 4 and you could use synthetic division, but it's not going to give you a remainder of 0. Oh, you mean if you put 4, would you get this? Probably 4, I'd have to check it, but 4 probably would come out with all positives. Is that what you're asking?
Yeah, if you did all positive,
I would imagine that it would tell you that. Yeah. So you're asking, is there only one up or down? That's why I would suggest you start in the middle and work out. What if we did 4? I'm just going to do it off to the side. So if I did 4 and number 3, I'd do 1, 2, 4, 8. Are you asking about that?
Like, are you saying, like, instead of 1, if you put 4 and then it gave you an upper bound, you wouldn't use 8?
Right.
Yeah.
But let's see what 4 gives us now. Let's just see. So we've got 1 times 4 is 4. Add down, you get 6. 4 times 6 is 24. Add down, you get 28. 4 times 28. 4 times 8 is 11. And add down, you get 120. So if you had chosen 4, you probably would have said that that was your upper bound. Right? Aren't they all positives? Because you might have selected 4 instead of 2. So for your purposes, that's your upper bound. Does that make sense? So if I saw your work and you did that, you would know that you wouldn't choose 8. You're right. But technically the upper bound overall is 1. But you wouldn't have known that because maybe you skipped 2. But that's fine. If I saw your work, I'd accept that. Yeah.
Is there more than one upper bound?
Well,
Looking at it on the
technically there
graph.
isn't. But what I'm saying is maybe when he's just hitting and missing with his choices, that instead of him choosing 1, let's say that he didn't choose 1 from the beginning. Okay, let's just say shot in the dark, he decided to start with 4. Then 4 would show him an upper bound, wouldn't it? So he would know not to choose 8. So then he'd start working his way down. My point to you is if you start in the middle and work your way to the right and the left, so work your way to positive, starting at 1 and working your way to the right, you'll find your upper bound typically quicker. It just depends on how many answer choices you have. I won't start from the biggest number and work my way down. I'll start from my smallest positive and work my way to the largest positive. Then I'll start with my largest negative and work my way to the smallest negative. It's just easier to find your true upper and lower bounds. Yes.
So, like, if it wasn't 1, we literally have to do 2, or you have to do 2.
Yeah, then you'd have to start with, right, exactly. But you're looking for that upper bound to stop that pattern of going then 2, then 4, then 8. Does that make sense? If you're not looking for this upper bound occurring here, then you might try 8.
So we knew because, like, we got zeros, or did we know because they're all positives?
We knew because they're all positives.
But those are all positive.
Right, but I knew here at 1, when we were testing for the multiplicity, I knew right here, they're all positives. That means I don't choose anything higher than 1. There's not going to be anything that's going to work higher than 1.
But it worked for the 4.
No, it didn't work because I didn't get a 0. I got an upper bound, and that's what I'm trying to say. Let's say that you didn't choose 1 from the very beginning. Let's say that this was the very first one that I chose. Very first one. I hadn't done any of the others. It's not a 0, right? But you would know that, okay, all those bottom numbers are positive. You'd know that 4 is for you, your upper bound. You should know that you don't choose 8. Because 8 is the only number in your possible choices that is bigger than 4. Does that make sense? So for you, it cut off one of your choices. For me, because I started with 1 and then checked its multiplicity all the way down, and I go, oh, those are all positive numbers. I know there can't be any positive choices bigger than 1, so I don't have to test 2, 4, or 8. That's why it's in your benefit to start in the middle, work your way out.
You should give us all 1s on this.
Yeah.
So
Cameron?
the only way you can actually find your upper bound is if you find the 0 first.
No. We had ones before where we didn't find the 0, but we found the upper and lower bound, like on 2-4, the very last, second to the last one. I think it was the last question on 2-4, where we just had to, which one is it? It's example 7. So like when we did examples, stop, because he asked a question. So when we did example 7 on 2-4, never did we find in our choices a 0. But along the way, we found the lower bound because we put a negative on the shelf and we had alternating positive and negatives. So I know that I don't choose any numbers less than -1. So on these choices, I'm not going to choose -3, -5, or -15. So that cuts my work in half. Then when we worked over here, and so these, not only did I not find a 0, but it's not an upper bound either when I did 1. So then I started working my way. I could have done 3, but by this time you were tired, and I know what the answer was. So so I decided to skip over and do 5. So when I did 5, we happened to find the upper bound. Now, if we had done 3, we would have found that it wasn't a 0, probably, or maybe it was. I don't know because we didn't try it. But I was specifically working on this problem to your upper bounds. But I would know on this one, okay, I'm not going to choose 15 because I found my upper bound. So based upon the work here, the only other number I have left to choose is 3, based upon all my work on that particular one. And if 3 doesn't work, well then, probably they're irrational and some imaginary. This one you weren't able to finish.
Oh, okay. Yeah, because it's not a number bound because it didn't end in 0.
Correct.
Okay.
Which one's not an upper bound?
The one you just showed us. That ended in 140.
Oh, no. No, it ended in 140. It is an upper bound because look at, you have all positives. Doesn't mean that that number ends in 0, but I have all positive numbers down here. And I put a positive number on the shelf. That tells me that 5 is my upper bound. It's not a 0 because I don't have a remainder of 0. But it is my upper bound, meaning there are no zeros greater than 5. So in all of my choices here, I'm not going to choose 15 because that's greater than 5.
Yeah.
So I'm not going to test it for synthetic division. You can do synthetic division, but it's a waste of your time. It's not going to work.
He said the 4, you can't do that because it didn't end in 0.
No. That's not what I said. You mean this one here?
Yeah.
I said they're all positives because it doesn't have a remainder of 0. It's not a 0. But Juan was saying, well, what if I chose 4?
Yeah.
Okay, well, if he hadn't ever chosen 1 in the first place on this problem, and he started off with 4, never started off with 1, this would tell him 4 is an upper bound.
Okay.
It's not a 0. And so this would tell him that I'm not going to choose 8s.
Okay.
So 8's out of my synthetic division. So then he maybe would go back and do 2, and then 1. But the way he's doing it, if he chose to do it that way, he'd end up with more work than me. Right? You know, it's a shot in the dark. You just never know. I mean, you could start off with 1 like I did, and it didn't work, and then it's a longer path than if you started from the right end to go in. You just don't know. But you have to develop a strategy and stick with it. Don't change your strategy all the time. You develop a strategy and stick with it. Most of the time when you use this strategy, you're not going to do extra work.
So like, if I started with 4 and I think I found my upper bound, and I did 1, and then I found another one, and it just completely crossed
No,
out my
because if 4 is your, no, 1 would not be an, okay.
Like if I did that whole process and I ended up like what you did there, finding like,
And
if I
that
did
and,
4
and there's
versus-
a problem with starting high and going low. I don't do it that way for that reason. I know that if I start low and go high, I'm not going to have that issue. Does that make sense?
Yeah.
Plus, I'm working with smaller numbers when I start low and go high. You saw how big those numbers got with 4, right? That's another reason why I start with lower numbers. Did I see a hand up over here?
Yeah, I was just wondering, for these type of problems on my test quiz, you want us to find the upper and lower bound, or is that just kind of?
I might ask you for that, but that's really more for your benefit as you're doing this shot in the dark with no use of a calculator. That helps you narrow down and shorten your work. Because otherwise, you're having to test all of them. And that's frustrating, it's tedious, and not fun, right? This makes it a little bit less tedious. Yes.
So you know how on how we're like how he did 4 or we did one of them, they became the upper bound. So what if you put that on Math Excel and they're like, no,
Oh, if they ask for the upper bound?
yeah, and you did.
I'm not
4
sure what they're
instead
going to
of
say
1.
because technically 1 is your upper bound. That's why I would suggest you go low, start low and go high with the positives, and with the negatives start high and go low, would be my suggestion. I haven't tested that out in Math Excel, so I'm not sure. You'll have to tell me. Would they accept 4 and 1 as upper bounds? My guess is no. My guess is that they're going to want this one. If I'm giving it to you as test, I'm going to understand by looking at your work what you've done. If I can't follow your work, then I might not give you credit for that either. But if your work's no sign number on my stuff, that'd be conducive to your work as well. Okay, so are there any other questions on this one? Okay. All right, so then look at example 2. We briefly talked about example 2 when we did this. So you were only originally given those 3 zeros. You were given -1 twice, which implies that -1 has a multiplicity of 2. So technically it's x plus 1 squared. I caution you writing it as x plus 1 squared because the majority of you are multiplying that out incorrectly over and over again. X plus 1 squared is not x squared plus 1. It has a middle term, FOIL it. So we'll do this in a minute. But then if you have one imaginary of 3i, you're supposed to know that -3i is its paired 0 because they have to come in pairs. So here are all of my linear factors. For the 3i, I have x minus 3i, and for the -3i, I have x plus 3i. My suggestion would be to multiply the imaginaries together first, multiply the non-imaginaries together, and then finally multiply the reals or the imaginary. So this one we need to multiply out. I'll talk about this one again in a minute. So let's multiply this one. when we FOIL, we get x times x is x squared. We get x times 1 is x. Then multiply the 1. 1 times x is x. 1 times 1 is 1. So you do get a middle term, which is x squared plus x is 2x plus 1. A lot of you are missing that middle term. When I multiply the x minus 3 and x plus 3i, this is the difference of two squares. If you don't believe me that it is a squared minus b squared, which is x squared, minus 3i squared, which is the 3 squared and the I squared, giving you 9i squared, then FOIL it. X times x is x squared. X times 3i is a positive 3i. Negative 3i times x is a negative 3xi. I think I missed the x on there. But they cancel each other out. And then these two are positive times a negative is a negative. 3 times 3 is 9. I times I is I squared. So you get this. What is I squared equal to? Negative 1. Negative 1. Because it's the square root of negative 1 times the square root of negative 1 is the number underneath the radical, which is negative 1. So that negative 1 times here changes the sign, so it becomes a plus 9. When you have an x squared, it changes the sign and the x squared goes away. So this is what I'm left with. Now we have to distribute. I'm going to distribute the x squared into everything. So x squared times x squared, x to the 4th, x squared times 2x, plus 2x to the 3rd, and x squared times 1, plus x squared. Then we're going to distribute the 9. So I've got 9 times x squared. So that gives me plus 9x squared. 9 times the 2x. That gives me positive 18x. And 9 times 1 plus 9. So now I've run out of room. So I'm going to collect like terms. I've got an x to the 4th plus 2x cubed. 1x plus 1x squared plus 9x squared is a positive 10x squared. Plus 18x plus 9. With 4 zeros, didn't we get a polynomial to the degree of 4? And you're kind of looking at that as a check. Are you okay with that? All right, so let's do the other one. The other one's written slightly differently. It says negative 1 with a multiplicity of 3. Doesn't that mean that this is, what's the linear factor for negative 1? X plus 1. If it has a multiplicity of 3, isn't it raised to the 3rd power? And then they have 3, which its factor is x minus 3, has a multiplicity of 1. 3 plus 1 is 4. Shouldn't I have a polynomial with a degree of 4? So I have 4 factors. I should have a polynomial to the degree of 4. So we're going to do our work on the back because we're not going to have nearly enough room. So see back. So write yourself in there. We're going to start with doing the x plus 1 cubed. And you're going to appreciate the shortcut one of these days when we do it. Because this can become tedious and I can actually have this multiplied out in seconds rather than what we're going to do. So this really means x plus 1 times x plus 1 times x plus 1. The answer is not x cubed plus 1. So I'm going to start off with multiplying these two together first. Didn't we just do that in problem 2a? Why repeat the wheel? Just write down what we came up with. Why reinvent the wheel? So we get x squared plus 2x plus 1. That's what we got when we squared x plus 1. So now let's distribute. X times x squared, x cubed. X times 2x plus 2x squared. X times 1 plus x. Then I'm going to distribute my 1. 1 times x squared is x squared. 1 times 2x is 2x. And 1 times 1 is 1. Collect like terms. We get x cubed plus, I have 2x squared and 1x squared, so isn't that a 3x squared? 1 plus 2, 3x plus 1. No, we're not done though, right? So that's just our x plus 1 cubed. So then we still need to do x plus 1 cubed times x is at minus 3?
Yeah.
Minus 3. So we're going to take this, well, I'm going to put the x minus 3 first because I don't like having it again. We're going to take the x minus 3, we're replacing x plus 1 cubed with what we just found. X cubed plus 3x squared plus 3x plus 1. So we get to distribute again. So I'm just going to multiply the x through. X times x cubed, x to the 4th, x times 3x squared plus 3x cubed, x times 3x plus 3x squared, x times 1 is x. Then distribute your negative 3. Negative 3 times x cubed, negative 3x cubed. Negative 3 times 3x squared, negative 9x squared. Negative 3 times 3x, negative 9x, and negative 3 times 1, negative 3. Now collect that terms. We get x to the 4th. The x cubes actually cancel out because they're opposite signs. Positive 3 and a negative 9 is a negative 6x squared. Positive 1 and a negative 9 is a negative 8x minus 3. Did we get a polynomial that's x to the 4th? The 1 was multiplied to the negative 3. Okay. So our answer is x to the 4th minus 6x squared minus 8x minus 3. Oh, you can see. Thanks for telling me. Whoop. There we go. All right, so any issues with that? So at this point, you ought to be able to finish 2-5. And so your job tonight is to make sure that all homework for 2-1 through 2-5 are completed by tonight. You have a quiz. Your quiz was supposed to be on Wednesday, but now it's on Thursday because we needed our review day to finish it up.